Hey friends, Jim here with Science Talk. Okay, more news from COP27. And this one is particularly troubling. But you've heard me say a lot of what I'm going to share with you, I've been saying for some time. Ocean warming moves faster and deeper, may double by 2100. And here's a lovely reef setting, some corals, various bunch of fish species swimming about, all endangered. Relentless ocean warming is leading to more supercharged storms, pushing marine systems to the brink and threatening the lives and livelihoods of millions of people, says a new scientific review. Unprecedented oceanic warming has been observed since at least the 1950s, reaching record values from 2012 to 2021, said the review published this week in Nature Reviews Earth and Environment. All around the globe, warming of the upper reaches of the oceans at top 2,000 meters has accelerated over time, reaching deeper and deeper depths. An international team of scientists led by Dr. Lijian Chang, an atmospheric physicist and ocean temperature expert at Beijing's Institute of Atmospheric Physics, Chinese Academy of Sciences, describes historic ocean warming as irreversible out to 2100. What happens next depends on whether global emissions fall and how rapidly, they say. Now, Dr. Lijian Chang is the gentleman whose graph I featured when I did both my ocean heat content videos, showing how the oceans have gone from not being able to efficiently absorb any more heat. And I indicated the turning point in the mid 1990s, the tipping point. So he has done some excellent work, this gentleman here. The findings underscore both the key role the oceans have played in helping to offset human emissions. Oceans absorb more than 90% of the excess heat trapped within the world's atmosphere. You've heard me say that before. And also the profound implications if the warming continues unabated. Well, there's going to come a point where the oceans will not be able to absorb that heat. Surface and subsurface ocean waters are projected to warm twice as much as they already have by 2100, even in a low emission scenario, find Chang and his team. Let's highlight that. Very important. Surface and subsurface ocean waters are projected to warm twice as much as they already have by 2100, even in a low emission scenario. The rate of these warmings in these waters has already doubled from 1960 levels, and in a high emission scenario known as RCP 8.5, and RPC is the representative concentration pathways, the rate could be 6 times as high over the next 80 years. Sounds a bit like exponentiation, does it? Does it not? The RCP 8.5 CO2 emissions pathway, long considered a worst case scenario by the international science community, is the most appropriate for conducting assessments of climate change impact by 2050, said Woodwell Climate Research Center, referencing research published in August of 2020. That's in spite of analysis over the last several years suggesting that RCP 8.5 is an unrealistically pessimistic assessment of future warming. I would disagree with that. RCP 8.5 might be actually a bit optimistic. In other words, it's actually worse. Now, I have done videos in the past where I've looked at some of the modeling being done where they've used RCP 8.5 or RCP 6 and other modeling pathways, and the result is usually that 8.5 comes the closest to replicating what's actually happening. And even the 6 and the 5 totally miss, but the 8.5 seems to do best, and even then it's a little coming in low. Complex mechanisms redistribute heat around the world's ocean. For example, warming has been greatest in the Southern Ocean, around Antarctica, which holds twice the excess anthropogenic heat as the Pacific. But don't forget that huge heat blob I showed you in the North Pacific. That's a ton of heat energy there. But uncertainties remain with pretty much no data on the impacts of eddies, tides, ice shelf cavities, and ocean ice shelf interactions. Eddies are very critical. They're like little miniature vortice entities within currents and so forth uh, that basically impact mixing. And if you look at, for example, the Gulf Stream, it's not just this ribbon of water squirting its way up, from the Gulf of Mexico area up into the Nordic seas. No, it's actually a whole bunch of these little eddies spinning all over the place. Some of the eddies pinch off, etc. So it's very complicated. How these interactions play out, especially the less understood ones, like the impact of the westerly winds on thermal mixing, will shape what happens next, said Jolyn Russell, a University of Arizona oceanographer whose research involves these examining these winds here. A small fraction more mixing would slow our warming. A small fraction less mixing would accelerate our warming. Russell, who was not involved in the latest review, told the Post that is incredibly important for people to understand. Now comes a really, alarming section here. Multiple stresses on marine life. The review summarizes the consequences of ocean warming. The most widely known is sea level rise, leading to saltwater intrusion, land erosion, and flooding. And it's not just flooding the coastal areas. If you've got a river basin like the Mississippi or the Amazon, rising sea level is going to pour right up into those valleys, right into those drainage systems. So it'll go right up the middle of continents. You've got a low-lying area, in comes the water. But warming also decreases ocean density, increases upper ocean stratification, changes which affect the vertical and lateral exchanges of carbon, oxygen, and nutrients, as well as heat. What have you heard me say countless times? I even did a video saying that a stable ocean is bad news for the planet because of the heating concentrating in the upper meters, upper layers of the ocean will lead to stratification. Very bad things going on. Warming also directly reduces the efficiency of oceanic carbon uptake and storage, as well as heat, especially heat sequestration. That's another thing. Okay, they talk about the vertical chain. If you don't have the thermohaline flow, you're not going to sequester carbon and heat to depth. They're going to linger in the upper layers. So if the warming reduces the efficiency of oceanic carbon uptake and storage, okay, that's not good news because the oceans are carbon sinks. Such impacts layered atop extreme weather events are poised to put substantial stress on marine ecosystems with impact on fisheries and aquaculture systems. It is projected that driven by multiple stressors, the maximum catch potential of tropical fish stocks in some tropical exclusive economic zones, EEZ, will decline by up to 40% by the 2050s under the RCP 8.5. The study also flags the higher risk of marine heat waves, MHW, with human-induced global warming and higher ocean heat content. it is inevitable that MHWs become more abundant, extensive, longer lasting. Effects from thermal stress causes mass mortality of benthic communities, including coral bleaching, changes in phytoplankton blooms, adverse effect on kelp forests and seagrasses, toxic algal blooms, shifts in species composition and geographical distribution, decline in fish and fisheries and seabirds. Okay, how many videos have I made discussing everything in here? I've been telling you guys this for how many years now? What is not mentioned here is also a decline in NPP, net primary productivity. If the primary productivity decreases, secondary productivity decreases, you know what happens? Whole ecosystems collapse. So there are major changes happening in oceans, and they're not good. We have the situation with the snow crab industry. Basically, what happened to 1 billion or 2 billion crabs? Where did they go? Did they move? Did they die off? Because of the changing Bering Sea. If the Bering Sea has warmed up so much, there's been a shift in the phytoplankton composition, right? Changes in phytoplankton bloom, well, you can say changes in phytoplankton species compositions. The bloom is basically referring to when they occur and to what extent and how strong. But if you shift from going from diatoms to coccolithophores, as what has happened in the Bering Sea, that's going to affect the zooplankton that graze on what they thought were diatoms. Well, where's their food? And then who grazes on the zooplankton, etc., etc. Whole ecosystems could shift. Now, I will save some comments on this towards the end. I want to cover the rest of this with you, but I'm kind of going to return to this and say a few more words. The destructive power of marine heat waves can be seen in the impact of the blob of warm water that floated in the Northeast Pacific and Gulf of Alaska from 2014 to 2016. The collapse of the regional ocean food web from heat stress reverberated up the food chain, ultimately killing nearly 1 million birds, notably murres, around 100 million cod, that's a pelagic fish, and hundreds of humpback whales. Well, humpback whales feed on fish. If the fish die off, so will the whales. Very disturbing, very troubling. And this goes back to what I just talked about, how entire food webs can collapse. Earlier, they mentioned about people rely on the impacts on fisheries and aquaculture, so on. Many people get the oceans is their source of protein. If we have collapses of ecosystems, we're going to have people going hungry and starving because their protein source is no longer available. So it's not just, hotter temperatures leading to crops withering and dying and causing, a hunger situation. It's also what goes on in the oceans. And don't forget, you mess around with the phytoplankton, if they start dying off, phytoplankton provide 55 to 80% of atmospheric oxygen. And we are measuring a decline in O2 levels in the atmosphere. Curbing emissions makes a difference, but all is not yet lost. Yeah. The review authors conclude, they're looking through rose glasses, I guess. Rapidly reducing emissions in alignment with the Paris Agreement, chuckle, chuckle, would probably lead to detectable and lasting reduction in the ocean warming rate with noticeable reductions in climate change impact, they write. Well, the problem is nothing is really being done on this front. But the world should be in no doubt about what the planet's rapidly warming oceans signify. The ocean is the memory of all this global heating, said Dr. Kevin Trenberth, a co-author and distinguished scholar at the United States National Center for Atmospheric Research, NCAR, Boulder, Colorado. This ocean warming is indeed relentless with huge consequences for sea level rise. Quantitative ecologist David Schumann of the University of the Sunshine Coast in Queensland, Australia, he's not involved in the review. He was a coordinating lead author of the ocean chapter in the most recent UN climate report, offered a powerful metaphor for just how much heat humanity has released into the Earth's ocean. The estimates in this paper suggest on average we have released energy equivalent to around 3.5 Hiroshima atomic bombs into the ocean every second over the period 1971 to 2018. The global ocean contributes in a very real way to almost every aspect of our lives, but this is often overlooked in favor of the things we see in front of us. Now, I want to return to all the stresses on the marine life. There have been basically 7 or 8 mass extinction events in Earth's history, or at least since the onset of the, from Cambrian times. I am part of a group of authors. We're putting together a review paper examining mass extinction events and the tipping points that can trigger them. I was asked, to write a section on what are the factors that lead to either a massive reduction in population composition in terms of number of individuals and so forth, or to outright mass extinction events. So I wrote the review and identified 4 major factors. There are others, but there are 4 major factors. The first is ocean warming. That's going on right now. The second is a increasing in the stratification. Mention that right here to you. Increases in upper ocean stratification. That is happening right now. Okay. The third is decreasing oxygen levels, increasing CO2 levels. Okay. That's going on. The increasing CO2 levels leads to an increase in acidity. In other words, a decrease in pH. That's a major reason why there's coral bleaching going on. And then the fourth one is a decrease in net primary productivity. When you examine in like 6 of the 7 or 7 of the 8 previous mass extinction events, at least 1 or 2 of those factors I just mentioned took place. Now, all of them are taking place. I also identified 2 other factors that are more recent. One is plastic pollution. We got plastics all over the place, from the Arctic Ocean down to the Marianas Trench. From stuff, plastic you can see, to microplastics you can't see, but little larval fish will ingest. I did some videos on that. I actually showed you a little film footage of a larval fish ingesting a piece of plastic. And the other factor is overfishing. You take all of these together, all 6 that I just mentioned, the oceans are dying, and humans are killing the oceans. And the sad truth is, and this was alluded to here by David Schumann, is that As we kill the oceans, we are killing ourselves. And that is no hyperbole. Until the next report.